Hi everyone, my name's Louisa. Welcome to DevParty. This is a series of online events organised by GDG leads from all over the UK and Ireland. Whilst I'm sure we would all love to be having meetups in person instead of online, it's perhaps a rare opportunity to get to know fellow developers from all over the UK and Ireland, and maybe even beyond, rather than just those from your local area.
Hi, this is Jen Ashley. We hope you will enjoy today and come away having learned something, as well as getting the opportunity to meet and discuss with other developers. You can keep up to date on our other events by following us on Twitter or Instagram using the handle at devparty underscore. You can also find us on Facebook and you can visit our website at dev-party.io. These links will be in the description below. So, just to quickly introduce ourselves, here are the people who organized this event.
Hello, I'm Mamta Gilani and I'm from GDG London.
Hello, I'm Swapnil from GDG Galway.
I'm Casey Nur from GDG Oxford.
Hi everyone, my name's Oscar McCauley and I'm from GDG Southampton.
Hi, I'm Jen Ashley from GDG London.
My name is Karthik Nooli and I'm from GDG Southampton.
Hi, I'm Antoine Danois and I'm part of the GDG London.
Hi everyone, my name is Goran from GDG London.
Hi, I'm Jason from GDG Milton Keynes.
Hey everyone, it's Dimitris Karavias from Londroid.
Hi, my name's Eddie and I helped put together this video intro. I have a YouTube channel focusing on open source. You can always catch me there.
Welcome to DevParty. All right, welcome to the GDG DevParty Flutter Day meetups. This is part of the larger Flutter Day event, which was a 24-hour session of live streams and code labs. Today we have two speakers for you that'll talk about various topics related to Flutter, and we hope you learn something and have a good time. I'm Casey Nur from GDG Oxford.
Thanks, Casey. I'm Goran from GDG London. And before we get started, we have a couple of housekeeping, so to say, for today. So the content for today is that there will be two sessions with a 30 minutes presentation and will be 10 to 15 minutes Q&A at the end of each session. So make sure you will write all your questions in the YouTube chat. So the speakers will be able to answer them after each session. We do have a code of conduct, as you can see onto the screen. So please do, if you're not familiarized, please do visit the link. And also don't forget to tweet or post or tweet on any social media using the hashtags GDG DevParty and Flutter Day meetups. So you will be entered into a draw at the end where you can win different prizes. So for today, we will be giving away 4 Flutter t-shirts. So don't forget to stay all the way to the end.
All right, on the agenda today, we have two speakers. The first is Karthik Nooli, a student at the University of Southampton, who is doing an introduction to implicit animations. And the second is Justin McCandless, an engineer on the Flutter team at Google, who is introducing the InteractiveViewer widget.
Awesome. So over to you, Casey, so you can introduce our first speaker.
All right, so this is Karthik Nooli. He's a student at the University of Southampton and a Flutter enthusiast. Without further ado, on to Karthik.
Awesome. Hello, everyone. Thanks for the great introduction, Casey. So today we're going to be talking about implicit animations and how awesome they are and how we can use them in Flutter apps to make awesome micro interactions and amazing apps. So without further ado, if the presentations will move. There we go. Awesome. So Flutter is a way of designing beautiful applications that are responsive, that are cross-platform with a single code base. So how does Flutter work? Everything in Flutter is a widget. If you see something on the screen, it's a component that's from a widget. A couple of examples of widgets are containers, text widgets, list views, rows, columns, buttons, checkboxes, literally anything you see on the screen is a widget. So there are two types of widgets. There's a stateful widget and there's a stateless widget. A stateless widget is something that doesn't update during runtime by itself. An example of this would be text. Text you can update through providing new parameters or changing the text provided, whereas a stateful widget can be changed by itself. An example would be a checkbox or a switch. These maintain state by themselves and don't depend on parameters coming in. So let's get to coding. Let's just switch over to the Android Studio project. So we've got the Android Studio project here, and I'm just going to go ahead and create a new Flutter application. Let's call it Implicit Animations with Flutter. Awesome. So if I hit next and then finish, oh, okay, apparently it's too long. Wait, yeah, that's good enough. Awesome. So over here, you can add Kotlin support for Android native code and Swift support for iOS native code. I have checked both of those, and we'll just give this a second to load up the new Flutter project. As you can see, we have the amazing Pixel 3 on the side as an emulator. So one of the benefits of using Flutter is a feature called Hot Reload. And this feature basically provides you the ability to show changes in your app straight away. You don't need to wait for the code to compile. It will just display the changes instantly, and we can show that here. So when we create a Flutter project, we're met with this. Hopefully the text is large enough there. So with this, we have a demo. Let's just load this onto the simulator real quick. Let's just give Android Studio a second. Awesome. So if I hit the play button, it should show up over here. It will take a second. During which we can look through the code. So we have a variable here called counter, and it's just an integer which has a value of 0. We have a function called increment counter that increments the counter by 1 and says reload this widget. All set state does is says something in the widget has changed, so we should re-render it and display it again on the screen. And the build method is going to describe what it's showing on the screen. So as I said before, everything's a widget. A scaffold's a widget, an app bar's a widget, text is a widget, everything's a widget. So if we just collapse this and have a look at what the scaffold provides. So the scaffold is a widget provided by the material library that allows us to lay out the application and provide the basic framework for what the app should look like. So if I have a look over here while the app loads up, let's just give it a second. Awesome. So this is the demo app that comes with all Flutter projects when they're first loaded up. And you can see here we have a floating action button with the plus symbol. And every time you click that, it will update the text in here. And all we're doing here is if we look at the floating action button code, we have a floating action button widget with an onPressed function where we provide increment counter, and the tooltip is increment. A tooltip is just a bit of like, oh, if I hold down on the button, it comes up with increment. And this is a parameter of the floating action button. And it has a child, which icon is add. And here we can change the icon to basically anything. Let's put in accessibility. And the second I save this, hopefully, awesome, we've got the button updated. And what's awesome is that it hasn't lost the state. So all of the content, the variable doesn't reset. It still stays the same at 2. So to demonstrate implicit animations, what I'm going to do is I'm going to get rid of this code to begin with. We just get rid of this. And we have an error over here, which I will fix in a bit. So what I'm going to do is I'm going to create a stateless widget called my home page. And this is just going to be the first page that you comes up. And we want a body. Inside the body, we want a center. We're just going to make a square that animates in the middle of the screen. So if I were to run this, nothing would show up because we haven't really put any content in. But what I'm going to do is I'm going to create a new widget called animated card. And I'm going to plop that in the center. So if I go over to the project and inside the lib folder, I create a new Dart file called animated card, and then make it a stateful widget, animated card, and let's just import the library. Oh, let's just make this a bit bigger. Awesome. So right now we only have a container, and inside the container, let's give it a bit of width. Oh, width is, let's say 200, and height is 200. And this is just going to show up in the middle of the screen. We want it to have a blue color. We need to import the material library to use the colors constant. Oh yeah, didn't fix the error earlier. So we have this error, which is because we haven't imported the new widget that we've just created. So if we import that, we get rid of it. And we don't have a title as a parameter for the My Homepage class. So the second I save this, we have a blue square. The blue square is nice and all, but let's make it a bit more interesting. Let's add some decoration, box decoration. And inside this, we get a couple of attributes. For example, let's use color. Let's make this, let's say, pink accent, which is quite a nice color from the material library, and remove the earlier color instance. And let's give it a bit of a radius. Awesome. So once we have this, if we save this, we've got a nice circular rounded off edges, and it's got a pink accent. But you're wondering, where does the interaction come into this? Let's wrap this inside a gesture detector, which gives us a couple of functions that we can use. We have on tap, on double tap. It even supports force, supports drag, on long press, tons of features. But we're going to be using on tap for now. So in the on tap, we're going to update a variable called selected, because we want to keep track of whether or not the variable, the widget is selected. So selected is not selected. And all it will do is every time we click on it, it will invert the selected state. And speaking about state, we haven't called set state yet. So let's just copy this into the set state method. And this will basically say to the card, to the Flutter tree and Flutter renderer, to update this portion of the screen, the portion that's being taken up by this widget. So if we save this, nothing's going to happen because we haven't added interaction yet. So let's say, for example, we wanted to change the color. Ooh. Selected. If it's selected, we want it to have a blue-gray color. Otherwise, we want it to have a pink accent color. And if I hit save, we have this. And every time I click on it, it will change color. Again, pretty boring, not too much interesting happening. So what I'm going to do is I'm going to add the animated container. I'm going to change the container into an animated container, which is one of the widgets provided by Flutter, where you can have implicit animations. You've got animated align, animated builder, animated container, crossfade, opacity, tons and tons of other things. I can go on and on. But here it needs a duration, and this is how long it will take for the animation to start and finish. So the duration I'm going to say is 500 milliseconds, and that's it. If we just format it real quick and then save it, come back to the emulator. Awesome. We have an animating container. And you might be wondering, what attributes of this container can I animate? And honestly speaking, it's nearly all of them. You can animate the height, you can animate the width, you can animate basically anything you see on the screen. So let's say, for example, we wanted to animate, let's animate the height, and question mark, and let's keep the width the same. Now, what's awesome about this is that animations can take as long as they want and will automatically be interpolated. But these animations look a bit boring. Let's add a curve to them. Let's do ease in out cubic. This curve will basically say it starts off slow, speeds up, and then slows down again. And then we end up with that, which is a lot better than what we had before. So you're wondering what happens about other widgets in the way. So what I'm going to do is I'm going to wrap this inside a column. And a column will just put widgets one below another, going down the screen. So if I just duplicate this and run this again, let's see what happens. Oh, it's going a bit off the screen. So let's bring this back a bit. Awesome. So now each widget will maintain their own state, and we can animate as much as we want. You see how one of the boxes pushes the other box down? It's an awesome feature about Flutter. It will handle most of the layout. So Flutter was created mainly as Google's UI toolkit and has been used across tons of apps. Some examples would be Reflectly, which is personally my favorite app. It's absolutely incredible the amount you can do with this. What else should we do? Let's say we wanted to animate the border radius. We can just add the same thing in here and can say that. And let's give it a bit more character. Let's make it elastic out. So when I save this, it's gonna bounce. These sorts of effects also, notice how it's quite sharp. That's because basically, if it's selected, it's going to have a border radius of 10. Otherwise, it's going to have a border radius of 0. So if we would change that to something like 50, it would have the same effect. And everything is done using this curve. If we slow it down to, let's say, 5 seconds, and see what the animation's like, you can see each an individual frame being handled. And the awesome thing about this is that we don't need to handle any of the manual frame drawing or interpolating all of the values. You just need to chuck an animated container into your view, and then you have an awesome animation running. And another thing about this is that if, say, for example, you were halfway through an animation and you wanted to go back, it won't jump. It will interpolate smoothly, as you can see here, which is awesome. So I'm not sure how much time I have left. I think I have 5 to 10 minutes. What else can we do? Let's give it a child. So as I said before, everything is a child of widget. So every class ends up being a child of widget. And we can provide children to the animated container by using a child parameter, which we're going to pass through, and animated card this dot child. Awesome. And then we can do child, and we can do animated card state this dot child. And all this is done is said that we want a constructor which takes in a widget, and we're just passing it into the state. And what we're going to do here is inside the animated container, if we look at this, we have a child, which takes a widget. So if we just pass the child parameter, this.child, and hit save. Oh yeah, forgot to give it a child. We just jump back here and let's give it a child of text. Hello world. And we can provide text styles as well. So text style. You've got colors. So let's make it white. And for this one, let's say we want a button. Probably not the smartest idea to have a button inside a component like this, but it's possible. Material. Let's use a flat button. Oh, flat button. And this requires a child text and hello world flat button, and it requires an onPressed, which we can provide an anonymous function for. So we can print pressed, and when I run this, we should see the changes straight away. Assuming I've got everything right. Okay, so this is still working. Let's do a bit of debugging. Just checking. Constructor, and we want a child. So what's wrong here? The awesome thing about Flutter is that it's got the Flutter inspector, so you can actually see where you've gone wrong. So I have a center, I have a column, and it says I've got two texts. So the animated card. So one thing about Android Studio is if you do Command P or Control P based on whether you're on Mac or Windows, it will show up with the parameters that you need. It might just need a full reload. Yeah, if we just give it a full reload. Yeah, awesome. So we have a flat button, which is taking up the whole page, which is why it's not really showing. And the text. Why is the text not showing up? If we remove the styling and do Control Shift. Oh. While we're waiting for that to reload. Yeah, it is there. Sorry, my bad. It is there. It was just hiding behind the status bar. Awesome. So that's implicit animations. There's tons and tons of ways to mess with these things. You can wrap implicit animations in each other, so you can have an animated opacity. There's tons of things that you can do, and it's absolutely incredible. So that's all from me today. Let's just go back to the slides real quick. Thank you all for listening. Google Slides, come on, there we go. Feel free to reach out to me on any of these channels. If you have any questions, drop them in the YouTube live chat box, and I'll do my best to answer them. So thank you.
That was awesome. Thank you so much.
Thank you.
Thanks, Karthik.
All right,
Awesome.
so we can move into Q&A. So if anyone has any questions, feel free to write them in the chat. We can look at some previous questions as well. So here was a recent one. The question was how to hide the top system bar in the app.
Awesome. So hiding the system bar is really easy to do. So you just wrap the scaffold inside a safe area widget, and that should, yep, that just kind of shuffles everything down. So cool.
All right.
Cool. That's really cool.
Oh, there was another question about scaling. So if I went to
Sorry, I didn't quite catch that.
If I want to show scaling up and down the container in a single click, how do we do that?
What do you mean by scaling? Is it like the height, or? Sorry, I'm not sure.
My guess would be yes.
So if you see here, the height is based on whether it's selected. So if it's selected, its height is 200. If it's not selected, the height's 300. The width stays the same, but you can obviously do the same thing. Make this an awesome square. So if I hit save for that, we have this awesome square. And if we remove a 0, we can make it back and go back to normal length animations. So yeah.
Awesome. I think the person was asking, maybe, do you know if it's possible by single click that you can have animation to scale up and down? Because like, for example, like from here, it goes to from 200 to 300, but can you do it to go from 200 to 300 and maybe back to 200?
Oh, yeah, I mean, like, so every time I click on it, the selected is getting inverted. So it's basically going backwards as well. So it's going forwards, then backwards, and forwards and backwards. And I'm just manually putting in the width and height. So yeah, it's possible. Anything you imagine is possible in Flutter.
I'll keep that in mind. Okay.
Any other questions?
Yes, they are actually. There is one question. What do you say? What happens when you import a widget?
Port a widget to iOS and Android, or?
This question came in by the time when you were importing material library into the Android Studio.
Ah, right. Okay. So when you import a widget, all it does is it adds the import statement up here. So the animated card is inside my lib folder. I'm not sure if people can see this too clearly, but it's inside my lib folder over here. I'll let Mac show it. Yeah. And it will just automatically recognize that it's being used. So I recommend using Android Studio or one of the other supported IDEs because they provide quite useful quick commands. Well, example is Alt Enter or Option Enter, and you can just wrap your widget, wrap with center. So say, for example, I very quickly wanted to wrap this text in a center so that it shows up in the middle. All I need to do is write the text in center, and if I just format that. Okay, it doesn't seem to want to wrap in center. It might be because of how I'm showing it. But yeah, when you import a widget, it will just go to the top and add an import line. Yep.
Cool. Thank you for that.
Another question, what libraries do you advise for more complex animations?
For more complex animations, it's very possible to do animations using tweens and interpolating manually. You can get a tween animated builder, you can get an animated builder, but I personally prefer using animated containers or animated foo with like micro interactions. So things that aren't a massive like animation that's going to be filling up the whole screen. They're just tiny things, part of the app, that are going to be updating like once or twice. Things like navigation bars, interpolating the color, that's really easy to do with implicit animations. But for explicit animations, I'd say use tween. There's tons of documentation on the Flutter website. So if you go to flutter.dev and look up the docs for animations, if we just open up flutter.dev and then go to the docs, and then there should be a section on animations, user interface, adding animations. Awesome. So we have this here, and we have a massive flowchart, which is amazing, for the different kinds of animations that you should use.
That's awesome. We have another question as well.
Yep.
Is it possible to scale to a higher index value?
Higher index value? Ooh. So I'm assuming you're talking about in terms of lists. For list animations, I'd suggest using the animated list. I know for a fact that flutter.dev does have a section about that, but it's quite deep in the doc, so I'm not going to attempt looking for it. But an animated list is reasonably easy to implement. You just pop this in here and make sure to give your widgets keys, just so that Flutter knows that it's actually changing. And an animated list just takes in a massive function which has a context, index, and the animation value. That's the best way to animate lists or like stacks or those sorts of things. Yeah.
Thanks.
Awesome.
There was a question, can we do animated backgrounds in Flutter?
Yeah. So because everything's a widget, it's super easy to just like wrap the scaffold inside. Okay, I mean, I'm not sure. I don't think I'd advise doing this, but it's definitely possible. Animated, let's just say animated card, and then remove the child. I strongly wouldn't. I'm going to be surprised if this works, because the animated card widget takes up like a portion of the screen, whereas scaffold is kind of like trying to draw that out. So it is possible to have animated backgrounds. I'm not going to try demonstrating it here today. That won't work well for me. Oh.
Okay, good. There is another question. Do implicit animations work on Flutter Web?
Yes, implicit animations do work on Flutter Web. I hear that they've recently added support for CodePen. I've been keeping up with the live streams, so feel free to check out codepen.io and check out the animations and the amazing work done by the Flutter team over there.
Yeah, I remember that one was introduced on the 25th. For those that missed that one, you can go to Flutter's YouTube channel and find over there the latest streams. It's quite useful over there.
Yeah, definitely.
Yeah, there was a couple of more that came in. There was one which I believe we already answered about where can I find out more about animations on Flutter.
Mm-hmm. Yeah, so just go to flutter.dev and there's tons and tons of content.
Also, and as for now, we have more. Casey, over to you for the next questions.
Yeah, so somebody said they were new to Flutter and wanted to know if there are job opportunities in Flutter, and are there like limits to the types of web and mobile apps Flutter can build?
I wouldn't say limits, but Flutter Web is still very, very new. So all of the packages don't have full support, but the amount you can do with what's already there is absolutely incredible. I've seen, I believe the Flutter Hackathon website was made entirely using Flutter Web. In terms of apps, your imagination's the limit. Flutter Web is definitely getting bigger and bigger, so I'd keep an eye out for that.
Cool, awesome. And another question: why is Flutter better than other cross-platform frameworks?
Awesome. So Flutter is a pixel painter. Which basically means that it's drawing out pixels one by one. And as slow as that sounds, it's built on C++ and the Skia engine. So it's super fast. Literally every pixel that you see on the screen is individually controlled by Flutter. And that gives you the flexibility of creating basically whatever you want using Flutter. You get incredible flexibility to do literally anything: animated, implicit animations, explicit animations. I believe on the Flutter website they have like examples from from the community. Here we go. So this is Reflectly, and as you can see, it's awesome. It's got tons of UI features, and all of the animations are absolutely incredible. And it has native performance, which means that rather than like converting it into, say, Java or Kotlin and laying out the heavy components, it is painting each pixel by itself individually, which means you can do incredible things. In one of the demos they had, I think it was a year ago, they had a Google Maps, like a working implementation of Google Maps in an animation that was like that was placed in a phone with the guy waving it, and it was awesome. It was absolutely awesome. So I'd strongly suggest Flutter because the amounts you can do with it are, your imagination's the limit.
Awesome.
Person from earlier who asked about hiding the top system bar wanted to know if there's a way to hide it in its entirety.
Oh yeah, sorry. Probably misunderstood the question. There is a way of doing this. Probably don't do this in your build method, but if I just very quickly double check, I mean, like, the Flutter community is what makes Flutter so amazing. So if I just search up how to hide status bar, it will come up with tons and tons of articles about how to hide it. And all you need to do is, if I just copy this line, copied the numbers. Probably, again, shouldn't do this in the build method, but it will work. And as you go, you've got it in full screen.
Nice one. We have a couple of more questions. We have one that came in, says, can we import React classes in Flutter?
I'm not 100% sure about porting React classes in Flutter, but I know for a fact that you can deep dive into the native code individually. So I'm not sure. You'd have to check the Flutter community for that.
Okay. Thank you. Casey, do we have any more questions?
Yes. So somebody asked, is Flutter for Web also pixel-based using Canvas, or what kind of technology is being used if we compile for web?
So Dart was originally built as kind of like an alternative for JavaScript. So like Dart has always had its fingers in the web for a long time. It's only recently that Flutter's come to web. I'm not entirely sure if Flutter's using a pixel painter for that. I believe so, but I might be wrong. Don't quote me on it.
Alrighty.
Thank you. And I think, do we have any more questions? I think we have no more questions.
I think that should cover it.
That you cover it. Okay.
Awesome.
Karthik, thanks very much for joining us today. It was a very great presentation with the live coding as well. And I think that we will have a little break, about 10 minutes, I would say, and then we'll come back to have a little chat with our next next speaker, which will be Justin. So Karthik, again, thanks very much.
Awesome. Thank you guys for setting it up and inviting me.
No problem at all.
Thank you.
Thank you.
Bye.
Awesome. So as we mentioned, at around 7 o'clock, we will have Justin, who is the engineer of the Flutter team. So around, I would say 10 to 7. So let's have Casey 10 minutes break. Sounds good?
All right.
Cool.
Great.
Okay, and we are back introducing for the next speaker, next session. Just a couple of things before we continue. As we mentioned before, we have a code of conduct. Please do visit that one if you're not. And also don't forget to tweet using the hashtags GDG DevParty and Flutter Day meetups. So tweet about the event and stay until the end to win. We will be giving out 4 Flutter t-shirts at the end. And also don't forget to post your questions in the chat. So we will be able to answer them during the Q&A session. Casey, do you have anything to add on that?
No, that covers it.
That covers it. Perfect. So before introducing the next speaker, we will have a little chat with Justin and give him the opportunity for him to introduce himself. So Justin.
Hi, everyone. Hi, thanks for having me.
Hi, welcome to our Flutter Day meetup.
Thank you.
Would you give us a little bit of introduction for yourself?
Sure, yeah. So my name's Justin. I have been with Google and the Flutter team specifically since about fall of 2018. So just before Flutter was 1.0, I started working on Flutter. And before that, I came from mainly a web background, so doing a lot of JavaScript stuff, and then was sort of just thrown into the deep end with Flutter starting then and been loving it ever since.
Awesome, that's great. Justin is joining us from the Bay Area, so I would assume it's morning over there.
Yeah, pushing 11 a.m.
Pushing 11, okay, cool. Thanks very much for spending this, I would say, mid-lunchtime with us.
Oh, and, yeah, no problem.
Yeah, how does it feel to be working maybe on one of the most rapidly growing frameworks today?
It's, you know, a lot of it is just because of the community is so great. It makes it a lot of fun just, you know, to know that all the code that I'm able to push and all the bugs I'm able to close and fix are helping people who are making all kinds of different apps all over the world. Apparently, it's something I haven't actually been a part of in my career very much before this, but it's been really awesome.
That's great. Casey, do you have anything to add?
Yeah, what are some like exciting Flutter developments that you're kind of particularly enthused about?
That's a good question. I think I'm really excited about Flutter expanding to other platforms. I think right now it's always something that's like upcoming and on the horizon. But you know, recently, like being able to doing development on a Mac, I can just run my app in the native macOS platform rather than having to spin up a simulator in iOS or an emulator in Android or using a physical device. Just it kind of like being able to do that as part of my usual development environment really brings that home that like that kind of stuff is coming. So I'm really excited about getting Mac support and even beyond that.
That's great. There's when I was watching the Flutter Day, the first stream from the on 25th of June, it was mentioned over there that I believe this is true because Flutter is open source, right? So is it true that you actually track all your I would say changes and all your milestone and all your brainstorming ideas publicly on GitHub?
Yeah, we try to do everything that we possibly can in the open as something that's accessible to the overall open source community. We see that Flutter is going to be something in the future that's going to be driven more by the community than by Google. So we're trying to turn it over to the community and bring people in as much as we possibly can. Probably the biggest thing that you'll notice in terms of like planning and things like that is these public design documents that we'll throw around on GitHub. I don't know if anyone out there has seen any issues on GitHub. Sometimes we'll link to a design document, which is sometimes it's someone within Google, sometimes it's someone external, writes up basically a really detailed proposal about something that they want to change to Flutter, often a breaking change to Flutter. And then we just allow everyone internally, externally to provide feedback on that and iterate. And so you'll see a lot of those design docs floating around, and we're trying to do more and more all the time to bring this kind of like not just the development, but the planning process and the ideas into the open source community.
That's great. Thanks for that. And also I've seen that lately also the Flutter Dev profile on Twitter hit a milestone, 100,000 followers. So congratulations on that one.
Yeah, thank you. That's an awesome milestone.
Yeah. I think I have no further introduction to be made for our next speaker. Casey, do you have anything to add maybe before we give the opportunity to Justin to start off with his session?
No, I'd love to. I'm excited to hear you talk.
Yep, that's great. So I will just add your screen. So Justin, today we'll be introducing the InteractiveViewer widget. And Justin, whenever you're ready.
All right, thank you guys. Let's get started. All right, so today I'm going to be talking about InteractiveViewer. This you might not have heard of it. It's a new widget that was just merged into master a few weeks ago, but it's something that I've been working on one way or another since actually I joined Flutter. I mentioned that was in like October 2018. So it was one of the first things that I ever messed around with Flutter. And so we're going to kind of hear a little bit about that story, how this came to be, and what you can do with InteractiveViewer. So I gave a little bit of an introduction about myself already, but I mentioned that I came from a web development background, and coming from that, I had done a lot of JavaScript, kind of similar to Dart. I had messed around with a lot of stuff in the browser, including a lot of custom rendering stuff with Canvas and SVG. So doing a little bit of visual things that are outside of what the browser is usually capable of, outside of those specific technologies. So when I first started taking a look at Flutter, I had seen the demos of building an app that looks like most other apps. It can do great animations really quickly. It can mimic what a lot of native widgets look like very accurately. I had seen all of that, but I wanted to try doing something that wasn't in the wheelhouse of Flutter and see how it handled that, because I really wanted to try to push it to the limits and see is Flutter something that I'm really going to care about and something I'm really interested in. So the first thing that I really built in Flutter, it kind of looks something like this. So it was I never actually built a game with this or anything, but I just built this hexagon grid, allowed you to kind of hit test the individual tiles, change their colors and things like that. And I went specifically after this kind of idea because this hexagon grid is something that would be really difficult from my experience on the web side of things. So in order to do this grid in the web, if I tried to do it in DOM, with the document object model in the web, everything is based on like right angles and rectangular elements, things like that. So first of all, just rendering something that looks like a hexagon might be a little bit difficult. Rendering something that looks like a hexagon in a grid where the bounding boxes, the rectangular bounding boxes of these hexagons overlap would make doing hit detection very difficult. And basically, all the benefits that are built into the web and doing UI in the web would kind of break down when you build something like this. So I specifically wanted to try this in Flutter to see how Flutter can handle this kind of thing. And I ended up being pretty pleasantly surprised in that I could still tie in to a lot of the built-in benefits that Flutter has with its setup of widgets and its whole event stack and how it does gestures and everything like that. I was able to draw these hexagons using Custom Painter, which allows you to kind of like Canvas, but on a smaller scale. You can draw whatever shape you want. But then I was able to bake in like the hit testing directly into it. I could do perfect hexagonal hit testing on each of these things and kind of treat them as a widget and just use the rest of the whole setup that Flutter has around doing layout and rendering widget trees and things like that as it is, without having to have like a black box on the web that's my hexagon grid and everything is custom inside of that. So I was really started off pretty impressed that I was able to do something so custom and access these low-level APIs. But from there, I wasn't done. I wanted to do something even more. I wanted to allow this to be more interactive with the user. And so I kind of wanted to do something like this. I wanted to allow the user to zoom in, to pan around, to focus down on some narrow part of the game board, to be able to zoom out and see everything that's going on, and have all these kind of interactions be really quick and snappy and everything. And so having been kind of spoiled by my experience drawing these hexagons in Flutter and having everything kind of tie in so nicely to the framework and everything, my first question here was, is there already a widget for that? Can I just pull something off the shelf and get this kind of functionality already? There are things like scroll view, things like that kind of give you a similar sort of thing. So I wondered if there's anything that I can do to get this out of the box. And at the time, the answer to that was no. Unfortunately, the answer nowadays is InteractiveViewer. And I'll go through the process of how we ended up actually bringing that widget into Flutter. But at the time, I had to build it myself. And so when I looked around at the existing widgets that Flutter had that might be able to get me close to this, I couldn't quite get it together by using things like scroll view. So I found something a little lower level called transform, kind of more of a niche widget. Transform, it can take a child just like anything else in Flutter, and any widget that you pass it will work, any widget subtree. It also takes a matrix 4 representing a transformation, and it will apply the transformation to the child. So in kind of a static way, it could do the kind of things that we were seeing in that GIF. I could scale things up, I could move them around the screen, but I needed to tie in the user's interaction to that and have the user be able to drive that in real time and have it feel like snappy and animated. So I started looking at Flutter's support for handling user input, and I came to gesture detector, which is a pretty common widget. A lot of you out there probably used this before. I found when I looked into it that it could do all of the it had support for all the things I really wanted, like pinching and using 2 fingers to drag, using 1 finger to drag, flinging, things like that. It really looked like it was solving all the use cases that I wanted. And just like transform, it could take any widget as a child and give it the capability of listening to user input. So this led me to start thinking about Flutter's composition. Flutter has this great composition model, which differs from something like classical object-oriented inheritance, in that we're not taking a widget and usually extending that widget into something else, but we're composing widgets together in their build methods and nesting them within each other. And that's what I wanted to do here. Basically, I wanted to compose the transform widget and the gesture detector widget and get something new that allowed me to pan my way around my hexagon board and get all that functionality that we saw before. So I put those together. I hacked it. I was still kind of a new to Dart, new to Flutter, but I hacked these things together, crammed it all into my hexagon board demo, and ended up releasing this shortly after I joined the Flutter team as a demo in the Flutter gallery, which is still there. I think I merged it probably like early 2019. The gallery's since been split off into its own app, but this demo is still in there. And it was great. It basically hit all the points that I wanted to get. It was performant for this hexagon demo. It did all the things I wanted, and I was really proud of that. It worked out. But from there, I started having people reach out to me. First of all, I talked to someone on the Flutter team itself, someone who's working on their own personal app, which had a table of a bunch of different data. And they wanted to be able to pan around that table in 2 dimensions. And similar to the problem that I had, they couldn't get that to work with scroll view or anything that existed already, but they wanted just, they wanted to compose something together with a widget that you just wrap around their table, and it's going to give you that functionality. And it was pretty similar to what I had done with the hexagon thing. So it got me to think, like, should there be a widget for this built into Flutter? Should we be able to do stuff like this? So I had this question coming in about the table. Meanwhile, in my pull requests and issues that I had opened about this hexagon demo and the work that I had done there, I actually had people reaching out to me randomly from the community asking similar questions. Somebody asked me, in addition, can I do a photo viewer with this? It's another thing that ends up being pretty similar to the hexagon functionality once you get down to it. So something that we can zoom in, we can pan around, pretty similar to what I did with the hexagon game board. I had somebody ask me, can you take any random Flutter widget and do some weird things with it, fling it around the screen, turn it upside down maybe, and even continue to use it like it's a regular Flutter widget. So yeah, actually nobody asked me about this, but Flutter is, everything's a widget. We should totally be able to do something like that. We should be able to put any widget into and give it this functionality of being able to pan and zoom around the screen. And if you want to throw a text view in there, that should totally be fine, And so I was kind of convinced at this point. I thought, yeah, we should be able to take this functionality out of my hexagon demo and build it into something that's reusable for all of these kind of examples. So that ended up being my idea for InteractiveViewer. And I wanted it to be something that you could compose just like any other Flutter widget, like you see here in this code. You can just wrap anything past another widget or widget tree to it as a child and kind of just like bring it alive and allow the user to then start panning and zooming and playing around with their widget in a way that wasn't possible otherwise and would otherwise take a whole lot of work hacking together transform and gesture detector. And so this is the like vision I had, and I wanted it to work for my hexagon demo, but I also wanted it to work for the use cases that I was hearing about, like the table and the photo viewer and anything else we can possibly fit into that. So in the rest of this talk, I'm going to look at these three examples and a few of the specific features beyond the basics that I had hacked into the hexagon demo and see what kind of stuff we had to add in as the API for InteractiveViewer in order to support all these different use cases and how you can use it to build your own kind of projects that use InteractiveViewer. So the first piece of functionality that I want to look at is the ability to limit the zoom level. So pretty basic feature. You imagine like in this photo viewer, first of all, in this one here, you don't want to allow the user to zoom out beyond where the photo fills the full screen. So you want to be able to set a minimum on the level of scale. But you also want to be able to set a max so that the user doesn't zoom in such detail that they can't even tell where they are in the image. Everything's blocky and pixelated. You want to keep the user in some value that makes sense for the application that you've built for them, and limit their zoom level between these two. And so we added just some simple parameters to be able to do that, called min scale and max scale. And these just take a double, and just as you expect, they limit the amount of zoom between the minimum and the maximum, and you get the effect that you see on the right. And by default, these are set to values similar to these two that kind of like give you a nice amount of zoom, but you can really set them to whatever you want. And down at the bottom, I've linked to the documentation here. There's a lot of good documentation about InteractiveViewer in the official Flutter docs, and a bunch of similar examples to the ones that we're going over today are in the docs. So if you're building something and you want to see exactly how to get some of these things to work, I'd encourage you to take a look at those docs, and I've sprinkled links throughout. So another example of something that we needed to support in order to support some of these other use cases for InteractiveViewer is the ability to disable zoom, as you can see in the GIF here on the right. So in some use cases, like in the table, it doesn't make sense for most tables that you'd want to allow users to just be able to use a normal zoom like we saw in the hexagon demo or the photo viewer. It makes sense to just lock that out. And so we wanted to add a Boolean to be able to do just that and prevent users from scaling if the application called for that. So we added the scale enabled parameter, which just takes a Boolean. By default, it's true. So by default, you'll be able to play around with the scale. But if you don't want it, you can always set it to false. And we've also added a pan enabled parameter. So you can do the same thing with pan. If for whatever reason you just wanted to allow zooming on the center of your widget and you didn't want to allow the ability to move things around, you can totally do that as well. So one thing that came up that was a little bit more complicated was the ability to both have children of InteractiveViewer that are bigger than the screen itself, or at least bigger than the InteractiveViewer viewport, because you could create an InteractiveViewer that takes up only half the screen or something like that, but you might want the underlying child to be able to be panned around and explored beyond the edges of the screen. So when you usually lay things out in Flutter, Flutter has a constraint system where the parent passes down to each child a set of constraints that tell it this is basically the size that you need to fit yourself inside. And so you can see, actually, I'm going to go back a few slides to the image viewer. So in this case, when it starts out, actually, the image fits the screen perfectly. And so we also need to support this use case as well. Using Flutter's usual layout and constraint system, there are a lot of different layout widgets that can allow you to position things nicely within the constraints that they're given. In the case of this image, images have a fit parameter. It works just like fitted box, another widget that does the same thing. And that allows you to pass a fit that can tell it, we want to fill the screen, scale it proportionally, but fill the screen. We want to cover the entire screen. We want to scale only in the X direction, only in the Y direction. A lot of different ways that the widget can fill the constraints that are coming in. And we wanted to support all that with InteractiveViewer. We wanted things to, by default, work just as if InteractiveViewer wasn't there and lay things out in the way that's most intuitive to Flutter developers. But at the same time, we knew a lot of these use cases are going to end up being things that are bigger than the screen, like this table, and like the hexagon demo as well, that overflow by default. And so we created another Boolean called constrained. And when you set this to true, it will pass infinite constraints to the child and allow it to draw as big as it possibly wants, including beyond the edge of the screen. So by default, this is going to be true. InteractiveViewer is going to behave almost as if it isn't there, and your layout will work just as you'd expect normally with Flutter. But if you want something that's bigger than the size that it's given, you can set constrained to false. So that's going to work out nicely. Whenever you're being able to pan and view things that are by default not visible from the start, you usually might want to look at using constrained. It's a parameter you definitely want to play around with when you're trying to get your layout right for your child of InteractiveViewer. And there's a similar example to what you see here is fully put in the documentation. So that's definitely something to take a look at if you're having trouble getting the layout right with InteractiveViewer. Another feature is a boundary. So in the case of the hexagon demo, you can see here in the GIF, I'm flinging the child to the left. The camera basically moves to the right, and eventually we hit an invisible wall there, and we're unable to view anything further out. So this is a nice feature to have. For the same reason that you might limit min and max zoom between two values, you kind of want to encourage your user to view the thing that you are designing for them to see and not be able to easily get lost, because you might imagine a strong fling like this could send them off into the black empty screen to the right, and they might not know where they are and how to get back to the hexagon grid itself. So it's nice to be able to keep them within some area, and we came up with the idea of boundary margin to do this. So boundary margin takes an edge insets. You might recognize edge insets from things like padding. The padding widget takes an edge insets. Usually anytime you're doing padding or margin, you'll use this class here. And what it does, it just specifies 4 values for top, bottom, left, and right. And so that's how the boundary margin works here. By default, the boundary margin is edge insets.all of 0. And what that means is that your child will have a boundary that tightly wraps it. So a good example of that is the photo viewer that we saw before. Jump back to that really quick. You can sort of see as we zoom out, it locks into that, and that's because the boundary is tight and it doesn't allow you to see beyond its fit to the screen with the 2 white bars as well. So that's the default boundary margin there. But then if you, going back to the hexagon demo here, if you set it to something like 100, what that's doing is adding an additional 100 pixels of wiggle room beyond the edge of the child. So you can sort of see, like, to the right of the edge of the hexagon grid, we have an extra 100 pixels or so of room that we can view beyond that, and it should be the same in all 4 directions. So that's how that works. If you want to set asymmetrical edge insets, so you want the vertical edge insets, the vertical boundary to be much higher than the horizontal one, you could totally do that as well with the edge insets class. And one last thing to note is you can see in the GIF here, when I fling it into the boundary margin, you can see it kind of hits it and then slides. So there's a little bit of like physics going on there to allow it to slide along the boundary margin, and that way it feels a lot more intuitive. If you also keep your finger or your mouse on the screen and drag against the boundary, you can kind of slide along it as well. So it feels pretty good by default like that. So here I want to talk about getting down into the narrow usage of the raw viewing into the internals of InteractiveViewer and seeing what's the value of the matrix that we're currently working with. And so that's what's being done in the GIF that you see on the right. So using a controller that we came up with, you can view the matrix and you can check things like what's the current zoom level. And you can react to that by, say, showing some detailed colors and things like that when the user gets close enough to something on the screen. So this, the way this looks is a controller similar to things you might have seen with like text editing controller in text field. There are a few other similar patterns like this that use controllers around the Flutter framework. But what these do is they give you the ability to listen to the value of something that this child widget is doing from the parent level. And so you can do things like this that you see on the right. But I want to show specifically what the code would look like to do something like that GIF showing. So this is how you declare a transformation controller. The identity matrix that you see here is just it basically means no transformation. So that's the root state of your InteractiveViewer widget without anything having been transformed. And because transformation controller is actually an instance of value notifier, so that means you can listen to changes in that value as well. So as the user interacts with the child and they pan around the screen and things like that, the matrix is constantly being updated. And if you add a listener to it, to the transformation controller, you can get called every time that changes. So immediately as the user is panning things around the screen, even as the physics animation is happening, as the pan continues after the user lets go, all of that is giving you a call to your listener here. And because transformation controller, the value and everything that InteractiveViewer is based on uses a matrix 4, there are a bunch of functions on there that are convenient for inspecting what's going on there. You can get the raw values, but you can also do things like get max scale on axis and check, in this case, have we zoomed in greater than 1.5 times, basically. And if so, you can call set state and set some value like show details, and then whatever you're rendering for your child can show the details and as we saw in the GIF, that might be like a bunch of different colors and things like that. So I've been talking a lot about like this matrix and how that kind of thing works. So I want to take a quick aside to talk specifically about what that means and how that works for anyone who hasn't encountered this sort of thing before. So this is the identity matrix, which we saw before. You can declare one with matrix4.identity. And what this is, it's just a 4x4 matrix of doubles. And the identity matrix itself is basically when it's applied to any point on the screen, the result will be the point itself. So it's kind of like multiplying by 1. Nothing will happen. No transformation is being executed. So if you want to actually do a transformation, in the simple case of just scale and translation, the matrix starts to look like this. So the S values here are the scale in the X and Y direction. In the case of InteractiveViewer, we don't do any stretching, which would be scaling in only the X direction and not the Y. Would be stretching in either direction, but we just do it proportionally, so the scale is the same in both those numbers. And the translation, that's the TX and TY, that is the translation in the X and Y coordinate. And that allows you to assemble a single matrix that represents both of these values at the same time. And then if you multiply that matrix by a point on the screen, or basically just an X and Y value, the ones are because we don't have a Z or anything like that, then the result is the transformed point. And this is how a lot of these kind of transformations work in computer graphics. And the reason is that when you combine all of your transformations into a single value as a matrix, there's no ambiguity between things like translation and scale, which one happened first. You know, if you're scaling the entire scene, it would be different to scale something when it's at the origin versus when it's somewhere off to the side. So you don't have any ambiguity there. If you do even fancier transformations like skewing or rotating and things like that, all these values work out into a single matrix that has no ambiguity and that can be run really, really quickly on computer hardware, even for in parallel for every pixel on the screen, and it can give you a transformed image very, very quickly. And so that's why we're using these matrices here in InteractiveViewer, and at the root of things, it's in the transform widget. So if you want to play around more with this, I have a link to an interactive demo that I think is on the University of Texas website. It's pretty cool. You can kind of like play around with these values and see what happens to an image that you provide. So I'd encourage you to check that out if you're interested. But I want to move on to another thing that you can do with controller that is active rather than passive. So we saw how you can listen to the value of the controller that's being set within InteractiveViewer as the user interacts with the screen. But I want to show you how you can programmatically set the transformation in InteractiveViewer and do things like move the translation to a specific point, zoom things in, like focus on a specific hexagon tile, things like that. So as an example, imagine the user's like zoomed off into some corner and they want to go back to the original start. They can press that reset button and have a nice animation that pulls them back to the starting position, back to where when they first opened this widget and saw this. So I'll let this run one more time. You can see what's happening there. I just click a button and it nicely animates me back to the starting position. So I want to show how you can do stuff like that using transformation controller. We see here that you can just directly set the value of the transformation controller. And what will happen is that the new matrix that you give it will be applied immediately, and the view will update so that the new transformation is being displayed. So what you would see if you did the code on the left is that it would jump immediately in one frame back to the home position. But here we're doing an animation. So I want to dive more deeply into how you can even do an animation with something like this. So this was one of the features that I wanted to build into my original hexagon demo, was the ability to go back to the home position, because it often happened that I would kind of get like lost and it was kind of awkward. I wanted to just be able to reset back to where I was. And being able to have an animation for that feels so much better and so much more intuitive for the user than just jumping there immediately, because you can kind of see where you're going and you realize, oh yes, I know exactly where I am in this hexagon grid. So I started looking into this, having not really done Flutter animations before, back in 2018. And I was really pleasantly surprised, again, by Flutter's animation library in that it's agnostic to the type that you're using for the most part. So you probably have done some animations already with Flutter. We've seen some in the previous talk. Often you might do them with, a really simple example. You might animate on a double, and maybe that's just going from 0 to 1, and we're animating like something like the opacity. So we're fading in. And the animation will provide, you start with the 0 value, 0 opacity, and then it'll provide you all the intermediate values, 0.1, etc., even on a curve in a very nice way, up to 1.0. But we can also do that with, you might have seen an offset, so we can animate between two positions, and it will provide the tween values between those. But you can also do that even with a matrix 4 itself. So you can pass to the begin value, you can pass the current location, the current transformation within InteractiveViewer. And for the end value, you can pass the identity matrix, which was our beginning, there's no transform yet. And we can animate between those two values using this animation. So just like you would do for any other animation, you can add a listener to the animation, and whenever you're called with the updated tween matrix value, you can set that to the transformation controller.value and get that for each tick of the animation, get that in between value as it moves from one position to the other. And the results of that is the GIF that we saw, this nice smooth animation from wherever the user happens to get themselves over to the original position. So you could do that with, you could swap this and say you want to begin where the user currently is and end, say, like zoomed in on some specific hexagon where something is happening in your game. You can do that as well. Any begin and end state is just a transformation matrix, and you can animate between those two. It worked out really nicely. I thought I was going to have to do a lot more work to get animations like this working, but it was really great that I could just use the matrix 4 as a type, and it would generate those tween values and set them directly like that. All right, so I want to look back briefly on what we talked about and talk about where you can go to build your own stuff in InteractiveViewer. So first of all, it's important to note that you can use any child for InteractiveViewer for the most part, like any widget that you can come up with in Flutter. We even saw the text field example. You can just stick it into InteractiveViewer, bring that alive, and be able to pan it around the screen. And that goes for any widget subtree as well, so you can put a whole bunch of widgets in there. And it works just like a widget like everything else in Flutter. When you want to get some specific behavior, went over a couple different parameters. These are all, like, as I mentioned, pretty well documented in the docs, which I'll post a link to right here on the slide coming up. So constrained, min scale, max scale, scale enabled, and boundary margin are usually the ones that you want to look at for these kind of typical behaviors. And then when you want to do more advanced things like getting direct access to the matrix for reading or writing, that would be a transformation controller. And these are kind of the main things that you want to keep in mind when you're designing some kind of experience with InteractiveViewer. And this link to the documentation here covers InteractiveViewer itself, which has a good overview of all this and like links to the detailed examples and docs for all of these. So definitely start there if you're looking at digging into InteractiveViewer. All right. So if you do start playing around with InteractiveViewer as well, I'd encourage you to even think about things that you can do beyond what we've seen today. There are a lot of issues that are open right now with upcoming work that we'd like to do with InteractiveViewer. So if you search for InteractiveViewer in the GitHub issue tracker, you'll find a bunch of those, or you can check out that link right there on issues. If you run into anything that's not covered, I'd encourage you to open up an issue. Feel free to tag me and go from there. We're definitely, this is a new widget, as I said, and we're really interested in being able to support as many use cases as we can. So I think there's still probably a good amount of things that we can do to make InteractiveViewer even better, even more generic, even more useful for more people. So feel free, we're pretty responsive about that now. Feel free to reach out. And if you are so motivated to even try to hack something in yourself in a pull request, that would be great. We're trying to get more and more people, as I mentioned a little bit before the talk, involved in the open source project. So I'm happy to help anybody who wants to open a pull request through the process, give code review and that kind of thing. Again, feel free to tag me, and I'm really excited to see more stuff of what people want to build with InteractiveViewer. So you can see my GitHub and my Twitter there. Feel free to get in touch, and thank you guys so much. Oops, there we go.
That's great. Thanks very much, Justin. That was quite informative and quite thorough as well. We do have a couple of questions that came in. Casey, we want to start off with the first question?
Yeah, so somebody asked, do you think this widget is a good fit for 360 view images? Or is there any other widget that would work well for this?
That's a great question of uses of interactive viewer that I hadn't thought of, but I'd like to support, just like I was asking for. So I appreciate the question. I think if you are going to build a 360 image viewer in Flutter, I haven't specifically looked if there's anything else that people have hacked together on Pub or anything. So that's probably where I would start. But if you do have to build this yourself, I think I would start taking a look at interactive viewer and seeing if you could do it. Especially if you want to have both like vertical and horizontal panning. I think you might be able to do it by setting up like a series of images that are looked at as the user rotates effectively the camera around. But there's definitely nothing currently built into Interactive Viewer that can do this kind of like 3D effect by default. But I mean, like I was saying, this is a great example of like pushing the limits. I'd be really excited to see if this is possible or not.
Great. So another question. Are there any widgets that don't work as children of Interactive Viewer?
Yeah, I mentioned, yeah, you can pretty much put any widget, just like anything else in Flutter, as a child and have it work out of the box. In terms of widgets that won't work, you might have some difficult behavior with a few things getting into the nitty-gritty. For example, I think there are a few widgets that use overlay, and overlay often uses the root overlay of the entire Flutter app, which in that case would be outside of the interactive viewer's transformation. So you might have weird behavior if you throw in something that's going to pop up an overlay and you expect it to be transformed and moved around the screen. It might not by default. So that's one thing to keep in mind and keep an eye out for if you are throwing obscure widgets into interactive viewer. But one way you might be able to get around that is you can always create your own overlay context that will grab the widgets that are looking for an overlay to position new children into. You can create one that's inside of interactive viewer that's a child of interactive viewer, and you might be able to get the effect you want there if you're looking for things that will be rotated as like a pop-up or an overlay within interactive viewer. So that's one thing to watch out for, but for the most part, things should work. I mean, there are also a few others, like if you try to do scroll views within interactive viewer, because of just the scrolling within scrolling, you might have a difficult time about that. But for the most part, the vast majority of widgets in Flutter should work. And if not, open up an issue and we'll see if it's something we can get working officially.
It's great. Thank you for that. We do have a couple. This is not directly related to the widget, but I hope you will be able maybe to give any insight on this one. So someone asked, recently I learned we can create Chrome extension with Flutter. How can I pass parameters to and from JavaScript methods?
Oh yeah, so I'm happy to answer any like broader questions about Flutter and things like that. But so in terms of this one, I'm probably not going to be able to give a good answer. Yeah, it is with Flutter Web, and even, we talked in the previous talk, there was a question about this, and we talked about Dart being originally a compiled JavaScript language. It is possible to interop between Dart and native JavaScript stuff, or rather like pure JavaScript stuff in the web. But I specifically have not, I definitely have not built a Chrome extension using Flutter. So I wouldn't know specifically what you need to do in that case for this kind of interop. But in general, yeah, it is possible to communicate between Dart and JavaScript.
Okay, thank you for that. Let me see for the next one. So there's another one. Can I somehow show widget inside widget only when I do zooming with the controller Infinity? As initially they won't be loaded until zooming in for performance.
So this is a great question and something that we've thought about for the long-term performance of Interactive Viewer. I think it's something we're definitely going to need to support officially. So the problem here for everyone else who's listening is that you might not want to load everything that could possibly be displayed by InteractiveViewer in the case that you have something like, as was mentioned in the question, like a lot of detail after being zoomed in that's not really visible from a high level if you can really zoom in far. Also, if you imagine like the table example that I talked about, if you have a very, very large table, you probably don't need to render a lot of the pieces of the table that are off screen for the most part. And so you can really speed up performance by not doing that. Unfortunately, that kind of behavior is not built into InteractiveViewer currently. You may have seen other places in Flutter where we do bake in that kind of functionality, like listview.builder is one example of that. So in that case, you can build a scrollable list view, and it will only build the widgets that are visible or very nearly visible on the screen. So if you wanted to do something similar with InteractiveViewer, you would have to do this yourself by manipulating the children that are passed into InteractiveViewer. So it would be possible, but we'd like to have official support for it in terms of probably some kind of .builder constructor like listview in the long term. But actually, I think in the specific case of this question, you might be able to do it without too much work, actually, because I showed that example of zooming in and showing more detail on the hexagons after a specific zoom point. So you could really take that example and do almost the same thing, and rather than changing the colors of the hexagons, change the children that are being rendered and render some more detailed children in there. And you could probably build something that works pretty nicely without too much work. So I would say you should totally go for it.
Great. There was a question about can we create a 3D gallery viewer effect using this widget?
So probably similar to the 360-degree image viewer, depending on how you want to implement this. Yeah, as I mentioned, all across Flutter, we don't really have that much support for 3D effects. So you're not going to get a whole lot of out-of-the-box great support for 3D things like this. But I mean, you do have, it depends on how you want to implement this 3D gallery and what you're thinking of, but you do have access with the transform widget and the transformation matrix that we saw. You can totally do like skew effects and things like that to that matrix based on user interactions and things like that. So if you want to get that low level in implementing 3D effects yourself, you could probably get it to work, but you're not going to, unfortunately yet, you're not going to find a lot of support built into Flutter for these kind of 3D effects.
All right. Somebody had a lot of questions about making like 2D board games. So they asked, given a board game, animations and some layout change, would you advise to try to compose the board out of regular widgets, or is there anything which is advised for 2D games, or any sort of widgets that are good for that?
Okay, this is a good question. This is kind of the same thing that I was wondering when I started just learning Flutter and I was making that little hexagon demo. Because coming from the web, I would have said it's not going to be possible to build this using the DOM, using HTML elements. It's going to have to be something custom. But I would actually say the answer to this is try to use regular widgets. Yes. When you cannot do something in a regular widget, like it will often come up in games, you want to draw something like that, the hexagons themselves, or you want to draw some kind of fancy sprites or things like that. You can actually use the same custom rendering under the hood classes that Flutter uses to draw even its basic things like buttons and things like that. You can access these core classes and draw your own Flutter widgets, still getting all of the support that Flutter provides for layout and things like that. So the thing you want to look for is Custom Painter. So Custom Painter is a class you should look for in the docs of Flutter. I think there's also, we have a lot of videos sprinkled out throughout the docs. I believe there's one for Custom Painter as well. If you don't see it in Custom Painter, look for Custom Paint. These are like similar related classes that work within each other. So that'll get you started. You can, using these kind of like Flutter's custom rendering stack, you can really draw whatever you want. You can do hit testing like the hexagon that's not based on right angles and boxes and rectangles. You can do hit testing on whatever you can come up with math, which is really important for games where you might have a sprite that is not a rectangle, So Flutter does have really good support for this, and you can fit a lot of things into just being widgets at that level. So I'd really encourage you to try to keep it as widgets, and remember to look at Canvas painters where you want to start. A custom paint, sorry.
That's great. Thanks very much for that details. We have another one that came in. Which, how resource intensive can this widget get?
It can get very resource intensive. The worst performance problems that you run into with this right now is in Flutter Web. So if you look at the issues that I linked, or just search for them on GitHub, you'll see there are some performance bugs open with Flutter Web right now. So there are a few things that we want to tune up with that. But beyond just the platform-specific things of the web, the main thing is the size of your child, right? So like we mentioned with the potential for a dot builder, like dynamic generation constructor, if you have an enormous child, it's still going to be running the transform on that child, even the pieces that are not visible. So you can easily get yourself into a place where you're using enormous amounts of memory and things are getting laggy if you have an enormous child. So right now, the main thing to keep in mind when you're thinking about performance for InteractiveViewer is if you do need to render something that's really, really big and is going to be clipped for the majority of it, you're going to have to do a little bit of work on your own in order to prevent the rendering of those pieces that are being clipped. Flutter's, as it is now, InteractiveViewer is not going to be doing any of that optimization for you. So keep that in mind when you're really pushing the limits of InteractiveViewer.
Okay, great. I believe we have a couple of more minutes to go through a couple more questions. We have another one. How do you go about testing user interactions in InteractiveViewer?
Sure. So we did a good amount of testing in the framework when InteractiveViewer was shipped. So if you look through our GitHub repository, you can look for a file called InteractiveViewer test. You can find that by searching through the code in GitHub, and you'll find a good amount of tests that actually test things like even like the boundary margin, things that will actually do things like fling a child across the screen and make sure it hits the boundary and make sure that it stops translating in that direction after that point. So Flutter has a pretty robust testing framework for handling things like user gestures and things like that. And it provides you a good framework for being able to put down even multiple fingers on the screen and moving them and stopping the clock and then inspecting things and then allowing the clock to continue and the widget to update and testing things as it goes along. So if you look at that file, you'll find a lot of specifics about how we tested that kind of stuff in InteractiveViewer. And I imagine if you have your own application for passing some different kind of child and you want to test to make sure these kind of things are working as you expect them, you can do really similar things to that. So InteractiveViewer test.dart in the main framework repository should get you started there.
Okay, thank you. Casey, do we have any more questions?
Yeah, there's one more. So it looks like folks are enthusiastic about 3D, so they're wondering if there is any plans in the future for like a 3D rendering engine in Flutter.
Yeah, lots of 3D questions. It's exciting. So currently, I'm not aware of anything being developed at Google to do 3D rendering in Flutter. We do have things, you know, like platform views and things. You can render a piece of native UI inside of a Flutter app. So right now, if you wanted to do something like that, you could maybe do something like use the native game setup in like iOS and then have some of the UI be done in Flutter and have a hybrid approach like that. But that would be what you would have to do. Or within the context of Flutter, you would have to write a lot of this stuff on your own. I've seen, we have no official support for any of this kind of 3D stuff right now, but I've seen some people actually do that within Flutter. Some basic 3D stuff has been done. We had the Flutter clock contest a few months back last year or earlier this year. And some people were doing 3D effects like that, like reflections off of surfaces and things like that. And they were writing that all custom themselves. So it is possible to do that. But for the most part, like we're based on Skia, which is a 2D engine. And so we're not baking a lot of this stuff into Flutter for 3D support. It usually will be something that if you want like an engine for that kind of stuff, you're going to have to look elsewhere and embed it within a Flutter app.
That's great. I believe we have no more questions.
Mm-hmm.
Yep. So Justin, thanks very much for joining with us today and for the presentation. It was quite thorough and very much enjoyed it. And I guess we hope to have you on our another event.
Anytime, yeah. Thank you guys so much for having me. This was great. I'd love to do it again. So keep in touch, and thank you guys.
Thank you.
Thank you. Thank you. Bye, Justin. Casey, what do we have next?
Should we, as prizes?
I think, yeah. I think now is the prizes. We have Jen Ashley, who will be joining the live stream, and we'll be able to do the. Hi, Jen.
Oh, I think you're muted.
Yeah, that was great. That was great, and you two were hosting it quite well. So yeah, we're on to the exciting stuff. You know, raffling prizes for people who joined us and have been tweeting. So let me share my screen so we can start the raffle again.
I hope we had quite a few people joining.
You will see my million tabs. Are you seeing my screen now or not yet?
Not yet.
No, not yet.
Just a second. Let's go back to. Okay. Right. Do that again. Can you see the wheel?
Yes, we can see it.
Yep. Okay. Okie dokie. So let's sort of maximize that so that everyone can see it. Sorry. Look, actually, before we do this, I just want to thank the Flutter dev team, you know, for supporting us for this event. Also, I know today is Nile Yenner's birthday, so happy birthday, Nile. I'm not sure if she's on the call, but happy birthday. Right, let's start with the raffle. So the first one. So we've got 4 prizes. First winner, Sisaba. I think he or she is from outside the UK, so that's not a problem. We can actually, we can definitely send you the prizes. I'll get in touch with you via Twitter. Congratulations.
Congratulations.
Renuka Kelkar. Congratulations. So I'll be in touch with you. I'm just making a note of the winners in case I forget, although this is recorded. Okay. Third prize. Jonathan Suresh. Congratulations. We will send you the prize. I'll be in touch because we need to get your sizes as well for the shirts. Okay, last but not the least. Ooh, okay, so it's Natasha. So congratulations. And that's it. So I'll be in touch by Twitter. I will coordinate. Thank you.
That's great. Thanks, Jen, for joining for the prizes. And I believe we are now to the last part, where we would just like to say thank you for joining today. It was great from me and Casey. Casey, did you enjoy today?
Yes. Yeah, thank you to our speakers and thank you to everyone for joining us. I hope you learned something. There are resources on the slide if you're interested in learning more and getting more involved in Flutter.
Yeah, as Casey mentioned, thanks very much for our speakers and for everyone attending today. And we hope to see you next time. Bye, everyone.